Hello, and today we're going to be doing another LeetCode problem, number 1007, medium problem, minimum number of domino rotations for equal row. So in a row of dominoes, tops I and bottoms I represent the top and bottom halves of the ith domino. Domino is a tile with two numbers from 1 to 6. We may rotate this domino so that tops I and bottoms I swap values. Return the minimum number of rotations so that all the values in tops are the same or that all the values in bottoms are the same. And if it can't be done, return -1. So effectively what we're trying to do is we're trying to see how many rotations can we make so that all of one half or all of the bottom half is the same number, and we're trying to find the minimum number of those rotations that we can do. So the key part of this problem is realizing that you can take a greedy solution to this problem, and that would effectively be doing it would be seeing, as we can see here, if all of the rest of the dominoes don't have either the top or the bottom number, then it can't be matched at all, because we need this to have two. We need to have this two, this two, this two, this two, and this two in order to swap. If this wasn't a 2, for instance, we wouldn't be able to do this, because it relies on every other domino following it to have a similar value. But what we can do is we can categorize this into 4 different possibilities. So let's say case 1, we match tops based on the first value in tops, which is top 0, right? So we're just going to go through all of tops and see, okay, is the tops value equal to 0 to this first element? No. Is the bottoms element equal to top 0? If yes, then swap it. And we're just going to go through all of tops, basically seeing if the top or bottom number is equal to the first element. I say we're just going to go through tops because effectively we're going to have a helper function that takes in both of these arrays, and because we know for a fact that both indexes will have the same length because of definition, every top has to have a bottom. So we can just go through this array, going through tops and seeing, is tops value equal to the first element? No. Is bottoms value equal to the first element? Okay, in that case, then we increment and then go to the next domino. This is top is matching the top, so we don't have to increment because we haven't swapped. This one, the bottom is equal to this, so we swap and then we increment. This one we don't have to increment because it's there, and this one we don't have to increment because it's there. So this is the first case where we can have all values on the top matching the first of top value. Then we have the second case where we go and match tops, but we base it on bottoms 0. So let's say we actually swap these first of all, the first domino first of all. So then we have bottoms on top. Basically, we just say 5. We're just trying to see if every other domino, if we can match 5. Just going through it, seeing if we can match any of these, if any of these have 5, and if so, we can swap them. Okay, so we've tried to do the tops one, and then the third case is just vice versa. We're just going to try and see if we can match anything on bottom based on bottom 0, and if we can't do that, we'll just try and see. We'll see if we can match it and by swapping the bottoms with the top, and if not, we have the general error case where we just return -1. Otherwise, we return the minimum number of swaps. So I think a helper function would be useful. So let's say, let's have a function called number of swaps, which takes in 2 arrays and a target value. And now let's say, let's iterate through the array. We can choose A or B, but we can just do A in this case. It doesn't matter really, because the first A is basically the array that we're going to be traversing. B is just the bottoms or the tops or whatever we're comparing it to. So we're going through A, seeing if the value matches, and then if it doesn't match, we'll check if B has the value, and if the other array contains the value, then we increment some number. If A contains the value, then we just continue, and if neither have it, then we know that we've reached a point where we just can't match anything, and we just return some error number, presumably integer max value. So we'll just increment here. Before the for loop, it's worth having a number of swaps variable set to 0. Okay, so let's do our first error check. So if I isn't target and B isn't target, then we just return integer max value, right? This is our error case, right? So if we know that A doesn't contain the number that we want, and we know for a fact that B doesn't contain the number that we want, then there's just no way that that domino will contain what we want. The greedy algorithm fails because we just don't have the first number, and we need all of these to have one common number in order to say that we can swap and match an equal row. So then we just return a false value. Okay, else if A isn't equal to target and B is equal to target, then we just increment num swaps. So what this is effectively doing, we've broken out of this so we know that we actually don't even need to write AI, but this is just we just do this for a bit more brevity and clarity. So let's say we go through our array. If neither value, neither A or B has neither tops or bottoms has the integer target, then we just return an error value. Otherwise, we check, okay, if A isn't target, but B has the target, then we just increment the swaps because we know that we've had to do some sort of swap. And we'd actually have to do a case for if A is equal to target, because in that case we just do nothing. We don't want to do anything because we only increment when we swap, when we have to do some swap. Okay, that's literally it. We just return num swaps, right? In this case, we've gone through the whole array, and we've just matched all the values, done all the swaps we can. This doesn't find the minimum. This is what we're going to be doing in this function here, right? So we're going to set a few variables. So we're going to say int tops top on top is equal to num swaps. We're going to be traversing through tops. We're going to use reference as our bottoms, and then we're just going to say, let's see if we can match top 0. And then we're going to have int bottom on top, which is going to be us using the bottom value on the top and seeing if we can match that. And that's going to be tops, bottoms, and then bottom 0. Okay, and then we have our top minimum, which is going to be the minimum between top on top and bottom on top. So what this is effectively doing is we're going to first run through we're going to run through the top values, and we're going to see if we can match everything on the top with the first value of tops, right? So we're going to see if we can bring 2 up to the top, if 2 is there, if we can bring 2 up to the top, and just see if top 0 is there. The second case is where we traverse through tops, and we are checking to see if we can match everything on top with a 5 with the bottom value on top. We're still traversing through the top, but we're doing an initial swap there. So we then look at the minimum between the value here, so top on top or bottom on top. And you may be thinking, why haven't you added 1 on this one, because you've technically done a swap already? Well, since we're starting from 0 and we're looking through all of the array, we will actually account for that swap here anyway, so we don't need to do that. So then after that, we find the minimum amount of swaps. Is it easier to swap everything on the top so that the top row is equal to the top number? Or is it easier to swap everything so that the top row is actually equal to the bottom number? So we find the minimum of that, and then we just do the same thing on the bottom. So we just say bottom is equal to num swaps. These are pretty dodgy variable names, but like we do what we do. So we do bottoms, then we use tops as our reference, and then we use bottom 0. So this is effectively searching through the bottoms array, and we're going to be saying, okay, how many of these next dominoes can we swap such that the whole bottom array is equal, the whole row is equal to the first value of bottoms. Okay, say that that's not good, or that's a large number, then we just say top on bottom as our new value, and that's just going to be equal to bottoms. We're going to search through bottoms and use tops as our reference, but we're going to be checking to see if we can swap the first dominoes and see if we can match the bottom row to match this value, the tops 2 here, and that would actually account for a swap there. So then we should find the bottom minimum. So this is basically finding, okay, is it easier for us to just match everything with the current bottom value, or is it easier, is there less swaps involved if we swap the first domino and then match everything on the bottom row with this value here that we've swapped? So 2 is now on the bottom. We're going to see if everything can be done to make sure that how many swaps does it need to make the bottom all equal to 2. If less swaps are involved to make the bottom equal to 5 compared to the swaps involved to make the bottom equal to 2, then we just take the minimum of that. So then we take the minimum of the 2 here, which is equal to math.min bottom, and top on bottom, right? Now, we say that the int minimum swaps, which is the ultimate minimum. So basically we're just going to see, is it easier to make the top equal to something versus is it easier to make the bottom equal to something? So this is going to be top on top minimum and bottom minimum. So all this line is saying is it easier ultimately to make the top equal to something compared to is it easier to make the bottom equal to something? Whether or not we have to swap, is there less swaps involved to make the bottom equal to anything or the top? And then all we have to do is say is return minimum swaps less than, we do a ternary statement here, integer.max value. So remember, integer max value was our error code. So if we found at any point there was a domino that neither the top or the bottom matched the first domino, even with a swap, then we return this very large number. If it's less than that, then we know that we've actually returned, we've actually gotten back some sort of reasonable number. So we just say return minimum swaps if we have a number less than integer max value. Otherwise, we return -1, right? So if we run this code, it works. And if we submit it, it works.